Hello everyone, thank you very much for joining the session on planning of sustainable microgrids. My name is Nina Rangel and I will be presenting a PV diesel microgrid planning tool considering the effect of biofuel blends operating cost. First of all, let me tell you about the structure of this presentation. I will start by giving the background of my research work and the objective of my project. Then I will be presenting the PV diesel planning tool and its applicability. Finally, I will be sharing the findings and the conclusions from the work presented. As a background, it is important to know that 840 million people around the world have no access to electricity, and about 600 million live in sub-Saharan Africa. So, finding solutions to the challenging situation addressed by the Sustainable Goal 7 to bring affordable and clean energy to all is the motivation of my project. It has been estimated by the World Bank Group that more than 7,000 off-grid systems will be required in order to achieve the sustainable goal, and most of these systems will be solar or solar hybrid. Currently, diesel generators are widely used to electrify off-grid areas as they have low capital costs. Nevertheless, they have high operating costs as they are commonly oversized and they usually operate below the recommended range. This creates higher environmental impact due to the unexpected consumption. All these flaws need to be solved during the planning stage of a microgrid to have better and more sustainable systems. Considering the background explained, the objective of my project is to develop a cost optimization model able to improve the operating conditions of diesel generators within PV diesel microgrids without battery storage for minimizing their operating costs and their environmental impact through biofuel utilization. Now, let me talk about the planning tool. As mentioned in the objective, I developed a cost optimization model, which is a Python-based algorithm that finds the optimum size and number of diesel generators to operate with the best fuel blend according to the performance of the diesel generator, the PV install capacity, the load profile, the biofuel blend cost, and the emission cost. I will be explaining a little bit more about these factors in the coming slides. The algorithm always considers a good engine performance by selecting only the generators that can operate within the acceptable power range, as indicated by the yellow box from the figure. In that region, the lowest specific fuel consumption values are achievable, and this leads to a proper fuel consumption. To estimate the fuel consumption of the generators, the algorithm uses the equation shown in the figure. This equation was found by fitting the fuel consumption data reported by 4 engine manufacturers that are widely used to assemble diesel generators. The equation gives a good estimation of the fuel consumption from diesel engines of any size operating at different conditions. The algorithm also considers the effect of available PV output power and the load demand on the engine's performance. This is relevant in the planning stage because having undersized PV diesel systems increases the fuel consumption as more power is required from the generator. It is also important to prevent having a high PV share and a low demand system because it will decrease the engine's performance, leading to higher operating costs. To visualize the applicability of the planning tool, I will present a case study of Piramiti, a rural area located within the Lindi region in Tanzania. The algorithm needs a load profile and a PV output power for selecting the diesel generators. Therefore, 3 load profiles were created using the load profile tool developed by the National Renewable Energy Laboratory. For each profile, the average load during the daylight hours from 7 a.m. to 6 p.m. was calculated for selecting suitable PV arrays to supply 40, 60, or 100% of that load. This was done to assess the impact of the load and the size of the PV system on the generator selection. For every PV array, the hourly output power was calculated with the help of the interactive tool from the evaluation using solar radiation data from the year 2016. A trusted K-means algorithm was needed to find three representative operating conditions for each PV array. The operating conditions include a high, a regular, or a low PV performance, and they would require different power from the diesel generators. Therefore, the operating cost will be affected. The other relevant inputs for using this planning tool are the diesel generator capital cost, the blend cost, and the emission cost, where both the blend and the emission cost are a function of the fuel consumption equation, and they are always affected by the amount of biofuel included in the blend. All of these costs are minimized in the objective function of the optimization problem, but you will see how the blend operating costs have a great impact on the final cost, depending on the operating conditions of the whole system. Here you have a summary for the best and worst case scenarios from the high and the medium low profiles, with their respective PV installed capacity and the PV operating performance. From the possible options, the best scenario was always the one having a high PV installed capacity with a high PV operating performance. This is attributed to the fuel consumption during the daylight hours and by having the right size of operating generators all the time. From the tables, you can see how for the same load profile with a different PV array, different engines are required and they have different operating costs depending on their fuel consumption. These are the optimization results from the low profile. This scenario uses similar PV arrays as those from the high and medium load profiles, but it has different operating costs due to the different load demand. Still, all the costs are minimized and the engine performance is within the recommended parameters to avoid unexpected fuel consumption and higher operating costs. I should mention that for the example presented, no castor oil was included in the blend due to the low diesel purchase price and the low carbon tax considered for the location. If this carbon tax is maintained, the castor oil price should be as low as 0.63 pounds per liter for the model to select another blend. On the other hand, if the fuel prices are maintained, the carbon tax should go as high as 70 pounds per ton of CO2 equivalent for the model to select a different blend. Finally, let me mention some conclusions of this work. It is possible to minimize the operating cost of diesel generators as it mainly depends on its performance, but we should be aware that it is easily affected by the load and the share of PV included in the system. We should remember that using a generator or a PV array of the same characteristics under different operating conditions will impact the final cost. Therefore, special attention should be given to the generator's performance during the planning stage for better sizing and selection without underestimating the fuel consumption cost or the environmental implications related to diesel or biofuel utilization. As the selection of a biofuel blend depends on the local prices, for sustainability reasons, the fuel selection could be predefined. This planning tool integrates all of these elements and could be helpful to design more sustainable systems. Thank you very much for your attention.
Thank you very much, Nina. Or it's Nina, are you? Can you unmute?
Yeah. Sorry, I was having technical difficulties. That's why I just asked you to share the video. But yes, absolutely, I'm here. So
no problem. That's why we have the videos for. So thank you very much for the nice presentation. I will check to see if there are any questions at this point. Not yet. Let me start off by asking a question myself. I seen that I will go back to what Shahab mentioned at some point about the availability of data. you need even more data for the work that you're doing. So you need data on carbon tax, on fuel, then it's a cost of transportation of fuel into different locations, PVs, because you need that, some estimation of the loads. So what was your experience on trying to get this data for specific locations? How easy was it? What assumptions did you have to do? Can you give a comment on that?
Yeah, that's really a tough question, because finding data, I think it's the most difficult part of any project, because as mentioned earlier during this session, there is not enough estimation of the electricity utilization, especially in rural areas or in such areas that are not really connected yet. So that was the first problem I faced, finding some load data. And then when I was trying to find different costs by the fuel, especially vegetable oils, it's quite hard to find them, because even though there is like a general understanding that they are being developed or being prepared in different places in the world, it is not really like a general knowledge on how much is that cost and if we are looking for specific prices. And so that was really terrible for me to do this cost optimization problem. But that's why I use certain tools to estimate, for example, the low demand, and well, fortunately there is another tool for finding the solar radiation and power output. But specifically for prices is really difficult, or was really difficult. Yes, that's what I say.
Okay. There is a question from Jasrul. It says, when we have diesel, there is high possibility the user will not really take care about PV maintenance. Any comments on this, since they will still be able to get electricity? So it means that diesel will have, let's say, as a backup, reliable, let's say, source, so they wouldn't take care of PV maintenance. Do you have any comments on this issue, although it's not directly in your...
Well, I could comment something that I think is my guess. And yeah, definitely when we have diesel generators, as they are really reliable, probably people wouldn't be as interested in giving the good maintenance. But that also happened for the engines. So I think it's like a rule for people that they are not used to give the real maintenance to different devices. And that's one of the main problems when we are operating microgrids for different systems, that we should be really educated to give the needed maintenance in order to avoid any other cost, because we need to renew the devices. So I think it's not quite related. By having the diesel, not giving importance to the PV, but just the way we are used to go through the different activities. And well, I think that would be something we all should work on, giving a priority to giving the right maintenance to all of the devices included in any system. Yes.
See, there's no other question. I have one more question. One of the things that was a bit surprising to me, well, not surprising, but it was about that the outcome was that the blended fuel at this moment is not really a cost-effective option. I think one of your conclusions was that unless the price of the oils that we use for making the blended fuel, or the cost, the tax on carbon emission is increased, or the price is decreased, then they are not the most cost-effective solution. Do you see this changing? I mean, do you see that they will become a cost-effective solution at some point?
Yes, it is expected from different vegetable oils to go to lower prices. But it's also true that I was taking the prices from the beginning of this year. It was from first months until April 2020. And well, we all know what happened to the general market, and the oil prices went down in a very, very drastic way. So by calculating with those numbers into my optimization model, that was the result that I have. But it is totally expected for the vegetable oils or in general biofuels to go a little bit down compared to diesel prices. Yes.
Okay. Thank you very much. I'm going to move to